This is the notes video for section 2.3, slides 13 through 16. So in section 2.3, we are learning how to find the derivatives of the trig functions. So sine, cosine, secant, cosecant, tangent, cotangent. All right. So first of all, we're going to start off considering the derivative of the sine function, but graphically speaking. So here I have a graph of the sine function. All right, so what I'm going to do is I'm just going to highlight a couple points. All right, so I'm going to start here, go up here, go up here, here, and over here. All right, so I have these 5 points. All right, so now this represents kind of the key points that we memorize when we're thinking about the graph. So this is sine of 0 is 0, sine of pi over 2 is 1, sine of pi is 0, sine of 3 pi over 2 is -1, and sine of 2 pi is 0. So now I want to think, what is the derivative? Remember, derivative, graphically speaking, means slope of the tangent line. So tangent line, this is actually at a special point where it starts above the curve and then goes below the curve. So if I draw that, this tangent line is actually pretty well drawn. If you see it, it actually looks like it's a slope of +1. And so that means the derivative of sine at 0 is +1. So I'm actually going to plot that point just so we can think about it. It's +1. All right. Then we are going to look at this one. What is the slope of the tangent line? Of course, that is 0. So 1, 0. All right, so then I'm going to plot that. So 0. All right, next. Okay, this is that special point that I talked about again, and it starts above, goes through, and then goes below. So if you think about it, this first one was +1, no question. But the second one, well, looks about the same, but it is negative. So that's -1. So then I'm going to plot that point. All right, so -1. All right, next one, of course, horizontal line right there. So its slope is 0. So then I'm going to plot 0. All right, and then lastly, once again, remember the trig functions are periodic. So the slope is going to go like this and then up this way, just like the one at 0. And so we should realize that that slope is +1. And so if I plot that, I get this. So now, if I connect these, we should recognize what curve this is. Okay, this starts at 1, goes to 0, -1, back to 0, back to 1. So this is actually the cosine function. So if we were to draw that, that is the derivative of sine. So derivative of sine of x with respect to x is cosine of x. So not too bad. All right, now how would we figure this out analytically speaking? Well, we would actually have to evaluate the limit as h approaches 0 of f of x plus h. So sine of x plus h minus sine of x all over h. Now, of course, then we would have to use some of what we know from pre-calc in order to solve this. So remember, sine of x plus h, we would have to write that out as sine x cosine h plus sine h cosine x, right? We would have to do that. Now, we don't really want to do that. So for our purposes right now, we're just going to understand that the derivative of sine is cosine. So this is definitely something to memorize. All right, moving on to slide 14. Similar thing. Now we're going to figure out the derivative of cosine with respect to x. All right, so now take a look at this. Once again, I'm going to highlight some of those key points. So 1, 0, -1, 0, +1. All right, so now think about the slopes of the tangent. So the slope here would be 0. The slope here would be -1. Slope here, 0. Slope here, +1. And then lastly, slope here is 0. So when I think about that, right, if I plot 0, -1, 0, +1, 0, I get this graph. Now, initially, people think, oh, well, the derivative of sine is cosine, so the derivative of cosine must be sine. Well, that is not true. This is not sine of x. What is it? Well, it's actually a reflection of sine. It's actually negative sine of x. So once again, this is something to memorize. All right, so now we know the derivative of sine, we know the derivative of cosine. All right, so now how could we figure out the derivative of tangent and then secant, of course, and then cosecant and cotangent? All right, so let's think about it. Tangent, okay? So you should recall from pre-calc that tangent is what? It's the sine x over cosine x. So this is actually just a quotient. So what we're going to do is we're going to use the quotient rule to determine what the derivative of sine over cosine is. Okay? All right, so remember, quotient rule says take the denominator, cosine x, times the derivative of the numerator. So derivative of sine is cosine x, right, from 2 slides ago. All right, minus. Okay, now we take the numerator, sine x, times the derivative of the denominator. What's the derivative of cosine? We just learned that. That was negative sine x, all divided by the denominator, which is cosine x squared. All right, so now that is the derivative, but let's simplify. All right, cosine times cosine is cosine squared. All right, minus sine times negative sine. So that would actually become sine squared x, all divided by cosine squared x. All right, so now in the numerator, cosine squared plus sine squared, that is the Pythagorean identity that is equal to 1. So we have 1 over cosine squared x, and we will remember that as secant squared of x. So the derivative with respect to x of tangent x is secant squared x. So go ahead, write that down here and memorize. All right, what about the derivative of secant x? All right, so once again, secant is 1 over cosine x. So we want to use the quotient rule once again. All right, so quotient rule says take the denominator, cosine x, times the derivative of the numerator. What's the derivative of 1? 0. Minus numerator 1 times the derivative of cosine. What's the derivative of cosine? Negative sine of x divided by the denominator squared, so cosine squared x. All right, so now cosine times 0, that is, of course, 0. Then I have minus 1 times minus sine, so that just be sine x divided by cosine squared x. All right, so that is the derivative. However, that's not the way that I want you to memorize it. So the way we'll memorize it is we're actually going to split the cosine and write it as sine x over cosine x times 1 over cosine x. And so sine over cosine, that is tangent x times 1 over cosine, that is secant x. And so tangent x times secant x, or secant x times tangent x, either way. So I usually write it as secant x times tangent x. So the derivative of secant of x with respect to x is secant x times tangent x. So once again, make sure you have it written correctly, something to memorize. All right, on to slide number 16. All right, so then how would we find the derivative with respect to x of cosecant x or cotangent x? Well, basically the exact same thing. So d dx of cosecant, remember cosecant is 1 over sine x. So quotient rule. All right, what is the derivative of 1 over sine? Well, quotient rule says to take the denominator, sine x, times the derivative of the numerator. What's the derivative of 1? 0, minus numerator 1 times the derivative of the denominator. Derivative of sine is cosine x, all divided by the denominator, sine squared. All right, so now sine times 0 is 0, minus 1 times cosine. That is negative cosine x divided by sine squared. So once again, this is correct, but this is not the way that I'm going to have you memorize it. I'm going to have you rewrite it as negative 1 over sine x times cosine x over sine x. And so 1 over sine is, well, there's the negative. 1 over sine is cosecant x times, and cosine over sine is cotangent x. So if we go down here, the derivative with respect to x of cosecant x is negative cosecant x cotangent x. All right, and lastly, the derivative with respect to x of cotangent x. All right, so remember, cotangent x is cosine x divided by sine x. So I'm going to use the quotient rule once again. So sine x, so denominator, times the derivative of the numerator. What's the derivative of cosine x? That is negative sine x minus numerator cosine x times the derivative of the denominator. Derivative of sine is cosine x, all divided by the denominator squared. So sine squared x. All right, so now I have sine x times negative sine. That's negative sine squared x minus cosine squared x, all divided by sine squared x. All right, so now I have minus sine squared minus cosine squared. So what I'm actually going to do is I'm going to factor out a negative 1. So I have sine squared x plus cosine squared x, and then divided by sine squared x. All right, so now sine squared plus cosine squared, that is the Pythagorean identity for 1. And so this is negative 1 over sine squared x, which we will remember as negative cosecant squared x. So the derivative with respect to x of cotangent x is negative cosecant squared x. So once again, these are 2 more rules that you must have memorized.